Oh, okay. Okay, 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 okay. Okay, hopefully you enjoyed it. Okay. Okay, next, once you prove it, so during the exam, right? I don't expect you to prove it, huh? So quickly just use the answer and then do the differentiation. So now you need to do the differentiation. Okay. So can you do it on the right hand side, the empty space? Slide 20. 1 mark. I leave it to you. Actually, my brain is pretty much drained already. This is my 5th lesson of the day. You know what? I should start early morning with you, so that I have like enough brain power to do all of these questions live. If not, I'm at a disadvantage. Okay, I'm pretty much drained, and then you ask me to do this differentiation, proving of trigo identities. They are all the, 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 the hardest part of mathematics. Huh? How do you differentiate? Come on. You need to open the bracket first before you can differentiate. You differentiate term by term. Okay, so maybe before you differentiate, maybe I just brief you on there are 3 ways to differentiate. Okay, let's go to slide 19 first. I also want to test you how good you are at differentiation. Maybe you're not good at all. How good you are at differentiation? You don't know. Okay, if I miss out anything, you have to fill up the blank, okay? Help me out. So uh, I have summarized it to three, okay? Three ways to differentiate. The first one is term by term. Okay? What do I mean by that? Term by term means you have the first term and then you have the second term. Then you differentiate it term by term. So the first one will give you 2 after the differentiation. The second one will give you 0, right? So it's 2. Okay? So this is term by term. So you always seek to do term by term because term by term is the simplest. Okay? Then if I'm not wrong, this is chain rule. Okay? Can you remember chain rule? What is chain rule? Yeah. Okay, so let me just try to introduce, make it like slightly more complicated. So if you have chain rule, what you do first is basically you can take the 2 out of the picture. So because 2 is a constant, you can take it out of the picture. So you just do the this one, right? So you differentiate the entire things first. Okay, then you differentiate inside. So it's like you peel back the layers of the onion. Okay, first layer, second layer. So you differentiate the entire term first, then you differentiate the inside. Okay, so you will get 3 3x plus 1 and then power minus 1. Okay, and then you continue to differentiate the inside one. Okay, maybe I should use a different color, which is 3, right? Okay, so therefore you get 2, then 9, 3x plus 1 squared, right? Then the 2 goes in, is 18, 3x plus 1, 2. Okay, so this is a chain rule. Okay, okay, the last one is product rule. I know there is this division rule, right, which I don't use so often. Not, what do I mean by that? So let me show you the product rule first. Let's say you get 2x squared times the what should I do? I cannot think of an example. Very interesting. Can you think of an example that make use of a product rule? Maybe just simple one then. Maybe something like this. Okay, so in a way, so I can get this into this. Hold on. Right. Okay. So product rule, what you can see this as is, you can see this as this. I know you can use quotient rule, but I don't prefer quotient rule. Just remember product rule. Okay. Then u equals to x squared. Then v equals to this expression, right? Then you du dx, right? So you get 2x, right? Then you dv dx, you get so minus 1 bring down, okay, x plus 1, so it's minus 2. Then you differentiate inside is 1. Okay, good, done. So you cross multiply, right? Okay, so you end up with 2x over x plus 1, then plus, so minus, so it's minus x squared over, so let me just get so far so good. This is product rule. Of course, some students, they will just they will combine this into a single fraction. Right? And x squared. But not necessary, yeah? So these are the 3 major categories. Okay? So with this understanding, then for this one is you should do term by term if you can. Always seek to do term by term. Okay? So you dA dθ. Can you continue for me? Right is smaller so that you have enough space. So my advice to you when you do the differential of a trigo, it's always good that you write down that that the trigo out. Okay, so you just refer to it. So this one will give you cosine 2 theta, and then you differentiate inside, so the 2 must be out, so this is correct. Okay, then when it comes to this, so you just do the 5000 times the square root 3. So this will give you the negative, right? So it gives, yeah, it gives you negative, right? So you just sine 2 theta, right? Yeah, so your 2 must go out also, right? So it's 10,000. Okay, so always write this out before you do. So that means it's going to like reduce the workload in your brain. Okay, so don't accumulate so much in your brain. You can't handle. Okay. Okay, so always reduce the workload in your brain. Okay, then yeah, then you need to solve this by doing what? Equate to 0 maximum, right? So in a way, right, you can take out the 10,000. So you can cosine 2 theta and minus this. So you divide by 10,000. So okay, then move this whole thing over, so it becomes plus. Right? Then divide by sine 2 theta. Or maybe cosine theta is better. Right? Does it make sense? Then tangent positive, right? So tangent positive is which region? Oh, science teacher, this one, right? The formula with the for this is theta is equal to alpha, and theta is equal to alpha plus 180, right? So yeah, so you write down A is equal to theta is equal to alpha. Then but here it's not theta, it's 2 theta, by the way. Okay, so you need to write 2 theta equals to alpha. In this case, but actually sorry, then I will just do this. So this is t is 2 theta is equal to alpha plus 180. Can you help me out using a calculator? So tangent inverse 1 over, I think it's a special angle, I don't know, help me out. 1 over square root 3. 30°, right? Okay, good. So therefore 2 theta is equal to alpha is equal to 30°. The 30° is in A. Okay, so therefore your this tangent is 2 theta equals to basic angle plus 180. So can you see that your basic angle is actually equals to 30, so it's equal to 210. Okay, so your theta is equal to 15. That's one answer. Then the other one is theta equals to 105. Okay. Then find the value for which the area of the triangle is maximum, right? So you need to prove that it's going to be a maximum. How are you going to prove it's a maximum? Yes, you set second derivative this, and then the to prove it is maximum is second derivative is going to give you a negative value or positive value. So negative is a what, frown face, right? Yep, so it's a maximum. Yeah, you need to prove it's going to be a negative value. Okay, so you just give so the theta here looks like 15 degree instead of the 105, so you need to reject that because it's acute. Okay, so you have to reject. Okay, but you need to consider the 105. Okay, so reject. Then after that you just key the 15 degree back to the question. Okay, to get the second derivative. So how do you get the second derivative? Can you do it one more time? Yeah, it's pretty annoying, I know. So 20,000 sine 2 theta with a negative in front. Then this one is 20,000 square root 3 cosine 2 theta, right? Yeah, so this is your second derivative. And you need to show that when your 15 degree you go inside, it's going to be a negative value. So it's 20,000 negative sine 30 degree minus 20,000 square root cosine 30. Yeah. How you can prove is a negative? How can prove? Because this can be a negative value. Negative can be a positive, right? So sine 30 is, if you get an indefinite answer, you just square it, then you get the, oh, it's half. Oh, nice. Okay, so good. Then what about the next one? Cosine 30. So it's okay, good. Okay, so then you can conclude that it's going to be a negative. Okay, I think it's good that you just get this answer out which is negative something so yeah, so second derivative is negative, so therefore the area of the triangle ABC is maximum. Because hold on the theta square is smaller than 0. Okay, what's your question again? Yeah, it can okay, it can be, right? That means you are asking this kind of question means you are asking, okay, let's go to slide 18. You are asking sine 2 theta equals to negative, right? Theta being positive. Uh, um, you need to use the basic curve. So when the cosine is negative, so this is 0, this is 180, right? This is 90, right? This is 270, right? So this is 360, right? When cosine x goes to the negative region, this one, right? So as soon as is in between this, I mean this x, so in a way you are talking about 2 theta, right? So as soon as it hit this one, you're going to get negative. So you can try theta equals to 46. So that will give you 92. Cosine 92 is going to give you negative, if I'm not wrong. Go ahead. Yeah. Why? Because like I say, it's negative for from 90 to 270, but exclusive of 90 and 270. Did I answer your question? Yeah. Okay. Good that you asked this question. Okay. Same thing for the sine. right? This is 180 to 360. So sine will go to negative region when your 2 theta is in between this range, exclusive of 180 and 360. Okay? Okay, sounds good. Okay, good. Next. Maybe we can do one more question. Let me clear the... We should be at slide 17. Thank you for giving me a less challenging one. Hopefully it's less challenging. But looking at it, it should be it's less challenging. So this question is pretty simple. All you need to do is you sub in the value. So there's your x coordinate, the y coordinate, just sub it in. Yeah, I'm going to show you. Okay? So 0 equals to negative k minus 2, right? So the modular sign, right? The modular sign here is this. The modular sign is going to, let's say if you have negative 2, you go to 2. You have 2, it will be 2. So the modular sign basically just make everything positive. Negative, positive, positive, positive. So that means positive, no change. Okay? Negative, flip to the positive. So if you have this, let's say this is the sine curve. So if I give you a modular sign, what you're going to do, all this one, all the negative region need to flip on top. And the line of symmetry is axis. Does it make sense to you? Okay. But this one still go on. This one still go on. It only affect the negative y value. Okay? Okay, so x-axis. No. Then your modular sign should be absolute the y already. So let's say you have this. It can be this case, right? Okay? Understand? Okay? So it really depends. Hold on. So over here, right? Just now what I say is your y is going to be negative y or y, right? These two scenario, right? But there is only one case that you can get 0, which is k equals to negative 2. That's the only way for this case. Right? To be 0, this entire thing has to be 0. Okay? But to be 2, then things can be different. This one can be 2, because 2 is going to give you 2, right? Then this one also can be negative 2. So you have 2 value of k if we are doing this question. But we are doing 0, so k has only one value, which is negative 2. Okay? Then sketch the graph. Okay, good. So just sketch the graph. And like I say, sketching a graph using your calculator is super easy, right? Yeah, just key it into your calculator and then you get the graph out. Okay, you get it into the calculator. In fact, I also have my so-called my graphical calculator. So let me use my graphical calculator on my side, and then you use your one on your side. So see, you get the same one as mine. minus 2x minus 2. Yep, I'm getting mine already. I'm going to upload to this page. Do you get this? Or something similar? They indicate the points of intersection. Intersection means this point. So this is negative 1 and 0. Then this point is the 2 and 0 and 2. So this is the y intersection point. And this is the x intersection point. Okay? Done. Hence, write down a range of value for y bigger than 2. So y bigger than 2. So that means you have this y bigger than 2 here. So anything above this line is how many, write down the range of value for x for y bigger than 2. So you need to get this bigger than 2. Okay? Right? Y is, okay, by the way, because, okay, I'm going to just do it. This is your y equal, right? So now they say y is bigger than 2, so therefore this whole thing is bigger than 2. Right? So when it's bigger than 2, you have two scenarios. It can be this, bigger than 2, or it can be this, with a negative in front, bigger than 2. Okay? So you need to solve this simultaneous inequality. Yeah? Oh, how? Yeah, good question. Thanks. Yeah, we're supposed to use hands, yeah. So x is in between, so this is bigger than 2, so yes, you are right. So in a way, right, we just use this. So in order to be y equal to 2, I think we shade this region, right? Right? Or below. Bigger means above. Yes, I should shade above. Right? Okay, so this region is x smaller than negative 2, right? This region is x bigger than 0. Yeah, correct. So yes, you are right. Let's use hence. Thank you. So hence we must use this. Okay? So bigger than 2. Okay, this is negative. Okay, good. Makes sense. Alright. Okay. One more. Wow, this 6 marks is so easy to get compared to the 4 marks proving. Like I say, don't do the proving at first. Let's go to slide 16. Let me go to the washroom and come back while you're uploading the picture, okay? Okay, I'm back. Simplify. Wow! You give me another crazy questions. How am I supposed to solve this question then? Teach me how. Okay, this is the logarithm question, which is log. So basically, use change of base. Why? Because you have this different base, right? So log 2 over log 3, then log 3 over log 4, then log 4 over log 5, and until log what? Until log 5 over log 6, until log n over log n plus 1, right? So can you see that this one always cancel each other? Sorry. Right, then the log 6 will cancel, right? So ultimately this one will be cancelled, right? Okay, so let's not do until this one first. Let's do until the log 6 first. So ultimately you will get the log 2. Let's say do this log 2 over log 6, right? Okay, so the first one, then the last one, right? So same thing lah. If you go until this this log 6 will be over, then this one will be this. You left with the log 2 over log n plus 1. Does it make sense? Then next, I think the next one is quite easy. Thank you for giving me an easy question. So certain questions are very easy to get, so please do those first. Okay, then for this is 6 x plus 1 is, you can see it as 6x plus 1 minus x, right? So it's times 6, right? 6 like this, right? They say let u, right? So this is u, 6u minus 6 over u, 5, quadratic. Right? Can you use your calculator? Because I don't want to use my brain anymore. Can you get the good numbers out of this? Something like this? Yes, it makes sense. So u equals to negative 2/3, and u equals to 2/3, right? No, 2 over 3. Or 3 over 2, which is 1.5. Okay? So therefore your 6x is this one. The 6x is this 1.5, right? So I don't think you can solve the first one because you're going to get error. Can you? This one, for x. So you're going to get log. You can't, right? Yeah, so this is error, right? Or undefined, right? And the next one is possible. Log 6, 1.5 equals to 6. Wait. So x, right? And then of course x is equal to log 1.5 log 6. That's how you get the answer for x. So what's x? Okay, something. 0. Yeah, that's what, leave it to you. Which one? Can you circle it? 5A. Never mind. This one is going to be this. Let me go to slide 17. So you have log 2 over log 3. This is change of base. So that means you have log 3. I mean log if you have yes. So I continue with that. I'm going to get this. So I will always delete I will only end up with this and this. So that's the reason why I picked the. So if you get this is log 2 over log 3, right? The last one is log n times log n plus 1, right? So therefore this will, you don't have these two. You only have these two left. It's okay. You don't have to. Because no matter what, they will cancel. Do you not see what I have done just now? Yeah. You can use log 2, but it does not matter. It will end up the same thing. So in a way, you don't get, this one will be gone, and then you will end up with the log 2 and then log 2 n plus 1, and this log 2 and log 2 bracket n plus 1 is also equal to log 2, I mean base 10 and then log n plus 1. Okay. Okay. Okay, I think we had a good session, right? Okay, yeah, good. So pretty intensive, I would say. I'm drained. I'm totally drained, by the way. If you're not, I don't think you are, but I think you are, because to absorb this much from me, it's going to be tough. Just by listening to it is tough enough. Imagine you have to do it. Okay, just by following is tough enough. Imagine you have to do it. Okay, so it's more than triple. Okay. Okay, but it's okay. So we have to take challenges when it comes. Okay. All right. So yeah, I think we have a good session. If you have no more questions, we can end the lesson today. Yeah. Okay. Good. So I will see you next Saturday. Yes. Yep. So I will continue to upload the homework. Yeah. Okay. Bye bye. Take care.